Okay, in this problem we have two blocks, a 6 kilogram and 2 kilogram blocks, and these two blocks are connected to one another via a string and are being accelerated towards the right by a pulling force of 40 newtons. So the way we're going to approach this problem is we're actually going to combine these two blocks and treat them as a single 8 kilogram block. It's being pulled towards the right by a 40 Newton force. And so we're going to use Newton's second law, which states that net force is equal to mass times acceleration. So we're going to plug our 8 kilogram mass into M here and 40 newtons into net force. So plugging these two numbers in, we get 40 newtons is equal to 8 kilograms times acceleration. And so solving for acceleration, we get 5 meters per second squared. Now what this tells us is that this 8 kilogram block here is actually accelerating towards the right at 5 meters per second squared as a result of this 40 Newton pulling force. And because this 8 kilogram block is represented by a 6 kilogram block and 2 kilogram blocks up in the original diagram, this tells us that these two blocks are also being accelerated at 5 meters per second squared as a result of this 40 Newton pulling force. And so I'm going to redraw these two blocks down here. So we have our 6 kilogram block, 2 kilogram block, and our 40 Newton pulling force. And so these two blocks are being accelerated at 5 meters per second squared. So this problem wants us to find the tension between these two blocks. So the way we're going to find this tension is we're actually going to ignore the 2 kilogram block and this 40 Newton force for now. We're going to focus on 6 kilogram block and the tension force that's attached to it. So I'm going to redraw only the 6 kilogram block and the tension force that's pulling on the 6 kilogram block. So this tension force that's pulling on the 6 kilogram block is actually the same as the tension force right here. So we know the mass of the 6 kilogram block is 6 kilograms, and we know that it's accelerating at 5 meters per second squared. So using Newton's second law, we can see that there's a 30 Newton force that's being applied on this 6 kilogram block in order to make it accelerate at 5 meters per second squared. And the thing that's applying this 30 Newton force is actually the tension. And so the tension of this string between the two blocks is what's causing the 6 kilogram block to accelerate at 5 meters per second squared. And so this tension force is actually equal to 30 newtons. And that's the answer.